Good evening, Lamai. Let's start the class for today's session, right? So actually today we are going to discuss about the complex Lewis structures. So with this lesson, actually we are concentrating on drawing Lewis structures with more than two central atoms. Lewis structures with more than two central atoms. That is what we are going to study today, how to do those things. Actually, we are coming up with a new special method to draw these structures actually in no time, right now, not consuming much of time, right? Actually, we are planning ultimately to draw a Lewis structure even in 10 seconds. Right, very quickly, we are trying to draw a structure by this lesson, by this technique, right? So actually, to draw a Lewis structure in no time like this, right, we are not going to count the electrons. We are not going for the electron count here, right? We are actually, what we are doing is just coming up with a very special method to draw the Lewis structures, even for the complex Lewis structures, right, without counting the number of electrons, right? Let's do this one, right? Before going to this thing, we should have some background knowledge, right? We should have some background knowledge. First, let's gather the knowledge we need to do the Lewis structures in no time, right? Okay, so it is like this. Let's consider some few simple Lewis structures to gather this idea. See, right? Let's think of few Lewis structures, right? Containing nitrogen. Let's see. So I'll draw a few Lewis structures first, right? If you are to consider, right, these things, NO2 minus, right? So the NO2 minus structure is this. This is NO2 minus Lewis structure, right? NO2 minus, right? Okay. Let's consider a few structures to get the idea correctly, right? So let's consider the NO3 minus, right? So NO3 minus is kind of this. Some simple Lewis structures we have learned so far. NO3 minus, right? So let's come up with another structure, right? See, some carbon monoxide. Carbon monoxide. If you draw the Lewis structure of carbon monoxide, it would look like this. Right? Let's come up with another one. NH2 minus. The NH2 minus, right? NH2 minus. NH2 minus. The Lewis structure of NH2 minus looks like this. Right. So let's look at these things and let's try to come up with some pattern here, right? Let's look at these nitrogens appearing here and there, the nitrogens appearing, right? So if you think of these nitrogens here, so you could see three kinds of nitrogens appearing with these structures. Here, some neutral nitrogen. Here, some nitrogen with positive 1 charge. Here, some nitrogen with negative 1 charge. Negative 1 charge, right? So these are the three nitrogens we could see with these structures, right? All the structures following the octet rule. So for second round unbills, the octet should be fulfilled. Without such, the structure is, right, not accepted, right? When fulfilling the octets for the nitrogen, octets means the 4 pairs, right? Octet means the 4 pairs, 1, 2, 3, 4. 1, 2, 3, 4. 4 electronic pairs. When fulfilling the octets of those nitrogen, right? If your nitrogen is with a neutral charge, if your nitrogen is without a charge, you have only 3 bonds. You have only 3 bonds. When fully filling the octets of the nitrogen, if the nitrogen is without a charge, you have only 3 bonds. If a nitrogen is with a +1 charge, you have 4 bonds. You are with 4 bonds with the nitrogen. Right? If you are with a -1 charge, that means you are only with 2 bonds with the nitrogen. Right? If you have to summarize, if you are with 3 bonds with your nitrogen, when fully filled in the octet, you are not with a charge. If you are with 4 bonds with the nitrogen, that means 3 plus 1. 3 plus 1. 3 is neutral, 4 bonds. Excess of 1 bond is there. Then +1 charge, +1 charge. 3 is the neutral situation when you are with 2 bonds. So 3 minus 1 gives you the 2 bonds. 3 minus 1 gives you the 2 bonds. Then you are coming up with a -1 charge. 3 bonds, no charge. 4 bonds means 3 plus 1, that means +1 charge. 2 bonds means 3 minus 1, that means -1 charge. So if you know the situation with, if you know about the neutral nitrogen, the number of bonds with that neutral nitrogen, then you can think of how many number of bonds should appear with the positive nitrogen as well as negative nitrogen, -1 charge. So this charge is related to the number of bonds with the atoms when fulfilling their octets. Right? See the same trend with the oxygen as well. If your oxygen is with 2 bonds, you are not with a charge. You are not with a charge on the oxygen. If your oxygen is with 3 bonds, 3 means 2 plus 1, then your charge is +1. You have excess of 1 electron, one bonded pair, +1. 1 bond. 1 bond means 2 minus 1. Then you are with -1 charge. See the pattern? If you are with 2 bonds with the oxygen, you are not with a charge, you are neutral. If you are with number of bonds excess higher than the 2 bonds, then you get +1 charge, plus charges. If it is 3 bonds, the +1. If you are with less number of bonds than the 2 bonds, you are coming with -1 charges, minus charges. So if you are with one less than the 2, it is -1. Right? That is the idea. Right? Let's see. Let's try to summarize these things in 2 tables. Then we would be able to see some pattern there. Right? Okay. So I am going to summarize these ideas in a table. Right? Right? So when it comes to nitrogen, right? Table would look like this. Right? So I am writing here the charge of the species, here the number of bonds, and here the Lewis structure. Right? Let's see this table with the nitrogen, the summarized table. Right? So if you have a nitrogen with 3 bonds, like this, or like this, 3 bonds, or like this, 3 bonds. The fourth pair should be lone pair. Altogether 4 pairs should be there, no, to complete the octet. So if your nitrogen looks like this in a Lewis structure with 3 bonds, your charge is 0. Your charge is 0. 3 bonds, your charge is 0. You are neutral. This is a neutral nitrogen. And coming with a summary of what we have learned so far. Right? If you are with 4 bonds, one plus than the neutral situation, like this. If you are with 4 bonds, this thing, or even this, or even kind of this, 4 bonds, anyway 4 bonds. So what would be the charge then? So there should be 5 electrons on nitrogen, but now you have 1, 2, 3, 4 only. 1, 2, 3, 4. 5 should be there. You have only 4. So the charge is plus 1. So all these situations, the charge is plus 1. Charge is plus 1. If you are with 2 bonds, one less than the neutral situation, like this, or like this, one less than neutral situation, you have to keep it in mind, you have to come up with the lone pairs to complete the octet. Then your charge is going to be 1, 2, 3, 4, 5, 6. Right? 5 should be there as it is group 15. You have now 6 electrons assigned. So minus 1. So here as well, 1, 2, 3, 4, 5, 6. It's minus 1. The charge is minus 1. So now you should see a pattern here. The neutral situation comes with 3 bonds. If you are with one more bond with the nitrogen, it is plus 1. If you are with one less bond, minus 1. If you are with 2 less bonds, than neutral situation, 2 less number of bonds than the neutral situation, it should be minus 2 then. 1 is actually 3 minus 2, so the charge should be minus 2. See, that should be, no, see, this is one bond with the nitrogen. To complete the octet, you should have 3 lone pairs. So altogether, 4 pairs are there. So if you count the charge on the nitrogen, there should be 5 electrons on nitrogen. Now you have assigned 1, 2, 3, 4, 5, 6, 7. So the charge is minus 2. So this is the situation in the nitrogen. So neutral situation appears with 3 bonds. Right? When you have more bonds than 3 bonds, you come up with plus charges. When you have less bonds than 3 bonds, you come up with minus charges. And the magnitude of charge is also related to number of bonds you are with. If you are with one more bond than the neutral situation, it is plus 1. If you have one less bond than the neutral situation, it is minus 1. If you have 2 less bonds than the neutral situation, it is minus 2. Right? So that is about the nitrogen. Right? What you need to do is actually just to remember the number of bonds when the atom comes with the neutral situation. Just remember the number of bonds which will appear with the atom with the neutral situation. Actually, this number 3, the magic number for the nitrogen, is not hard to remember. This magic number, the neutral situation's number of bonds, is actually not hard to remember. Why is that? Because this is the number of electrons it needs to complete its shell, complete its valence shell. We know nitrogen has a group 15 element, right? It is with 5 electrons at the valence shell. So to complete the valence shell, it needs another 3 electrons. That is this number. Number 3, the magic number of nitrogen, is actually the number of electrons it needs to complete its valence shell. That is the magic number. With that number of bonds, right, your nitrogen is going to be carrying a 0 charge, neutral nitrogen. If you have one more bond than neutral situation, it is +1, one less bond than neutral situation is -1, two less bonds than neutral situation is -2. Right? This is about the nitrogen. Let's do the same thing with the oxygen as well. Let's do the same thing with the oxygen as well. Right? With the oxygen as well, we can think of the same thing with the oxygen. See, first we need to absorb this pattern, right? This is what we are using then to draw the Lewis structures in no time, right? This fundamental knowledge should be there. Then without counting the electrons, we are able to draw even the complex Lewis structures which are with more than 2 atoms in no time, right? Now we are referring to oxygen. See, here the charge, number of bonds in Lewis structure. Right? So oxygen's neutral situation should come with 2 bonds. Why I am saying so? Because oxygen is group 16. Right? So needs only 2 electrons to complete its valence shell. Group 16 means 6 electrons are there with the oxygen. So by absorbing 2 electrons, it will complete its valence shell. So the magic number for oxygen is 2. When oxygen is with 2 bonds, its charge is 0. So you know that, right? When the oxygen looks like this, the charge is 0. When the oxygen looks like this, charge is 0. Right? Okay. So let's come up with other things. When oxygen is with only one bond, what should be the charge of that thing? According to pattern, the theory just we have learned, if we are lack of one bond compared to the neutral situation, the charge should be -1. If you are with 3 bonds, that means you have one excess bond than the neutral situation, so charge will be +1. If you are with 4 bonds, that means 2 excess than the neutral situation, your charge should be +2. 2 excess +2. 1 less -1 compared to neutral situation always, right? So if your oxygen is like this, you know the charge is going to be -1. You can count the charge. The oxygen is like this, you can count the charge. +1. Could be like this even. Could be like this. So oxygen should have 6 electrons, but you have now 1, 2, 3, 4, 5. 6 minus 5 is +1. If oxygen is like this, carrying 4 bonds, or is like this, all the 4 bonds are bonded pairs, then you should come up with +2 charge. See, you should have 6 electrons. Now you have given only 1, 2, 3, 4. 6 minus 4 is +2. See as well, 6 minus 4 is +2. Right? That is how the charges are distributed with the number of bonds. Understand the charges here as well, right? So -1 here, -2 here. right? That is about the oxygen. That is about the oxygen, right? At a neutral situation, the magic number comes with actual number of electrons you need to complete your valence shell. That is your magic number. The number of bonds at your neutral situation is a neutral oxygen. Right now? Keep it in mind, you have to always put these lone pairs to complete the octets, right? To complete the octet, complete the 4 pair situation, you definitely need to put the remaining pairs as lone pairs after writing the bonds, right? Okay, let's come up with the carbon as well. The carbon. Let's draw the stuff for the carbon as well. See, for the carbon. Let's do the same stuff with the carbon. Right? The carbon situation, right? So here, the charge, number of bonds, structure for the carbon. So for the carbon, the neutral situation should come up with number 4, because the carbon with the carbon, as it is group 14, you have 4 electrons there. To complete its octet or the complete its valence shell, it needs 4 more electrons. That is your magic number for carbon, right? So carbon is neutral if you are with these kind of Lewis structures. No need to add lone pairs, right? As all the 4 pairs are bonded. So if you are with 3 number of bonds, then you should carry -1 charge, because 3 is actually coming from 1 less than the 4. So charge should be -1. If you are with 2 bonds, the charge should be -2. If you are with 1 bond, 1 is 4 minus 3. 3 less than 4, the neutral situation. That means charge should be -3. See, if your carbon is like this, 3 bonds, to complete the octet, there should be a lone pair, right? So it could be like this. With the carbon monoxide, you had seen this thing, so its charge should be -1. If you need, you can count. Carbon should have 4 electrons, but now we have assigned only 1, 2, 3, 4, 5. 4 minus 4, 5 means -1. So carbons could look like this as well, or like this. The remaining should be lone pairs, right? So then your charge should be -2. So if your carbon comes up with only 1 bond, to complete the octet there should be 3 lone pairs. Then your charge is going to be -3. Right now? So this fundamental knowledge should be known to draw a Lewis structure in no time, right? So quickly draw these ones, or you can have a key screen capture quickly, right? Then you can complete the notes. So I'm going to use this thing to do a Lewis structure in no time, right? To accomplish Lewis structure in no time, I'm going to use this thing, right? So quickly have a screen capture, right? So I'll be here. So have a screen capture quickly. Then you can complete the notes, right? So with this, you clearly see that the carbon can't have positive charge. Carbon can't have positive charge in your Lewis structures. Carbon can't have positive charge in your Lewis structures. So if a carbon to possess a positive charge, the carbon should have 4 plus 1 bonds. If carbon to possess a plus 1 charge, carbon should have 4 plus 1 bonds. It is 5 bonds. So 5 number of bonds can't be there with the carbon. No, the carbon is a group 2 one, so octet is the maximum that guy can go for. So carbon can't possess 5 electron pairs, 10 electron pairs, right? 10 electrons can't possess that, right? So carbon can't have plus 1 charge in your Lewis structures. See that? If you have to possess plus 1 with the carbons, you should have 4 plus 1 bonds, 5 bonds. 5 number of bonds can't be there. Right? The octet means 4 pairs around the carbons, around the atoms, right? For the carbon, nitrogen, oxygen, second row nonmetals, octet is a must, right? You can't exceed the octet, right? And you can't limit the octet as well. You can't have deficient octets for the carbon, nitrogen, oxygen as well if you are dealing with an even numbered electron count, right? So that remember, octet is a must. So when fulfilling the octets, these are the situations with the carbon, nitrogen, and oxygens, the second row nonmetals. Almost all the complex Lewis structures are based on second row nonmetals. Almost all the complex Lewis structures, you can go through those complex Lewis structures in A-level papers, right? The question 1, the structured paper. You can go to those and see almost all, 95% of the Lewis structures, the complex Lewis structures, means when you have more than 2 central atoms. Those are basically about the carbon, nitrogen, and oxygen, the second row nonmetals. So completing the octet is going to be a must, right? So that these things apply, the relationship between the number of bonds and the charges, right now. Okay, let's use this one. Let's use this these ideas to draw a Lewis structure, a complex Lewis structure, which is with more than 2 central atoms in no time. Actually, I'm saying you, if you are to grab this thing correctly, you can draw this structure even in 10 seconds. Even in 10 seconds. See, let's try this start. Right? Let's try some few structures. Right? Okay. So I'm going to erase this one, right? So we'll draw few Lewis structures, complex ones, right? Right. So I'll come up with the structures given in your note. Right. There are few structures at the page number 16 in your note. Right. I'll draw those things. Then we'll draw one by one. First, they have given you the CN2O2 molecule. Its skeleton is given like this. Right. Then they have came up with C2H2N2O, no? Yeah, that one. The skeleton is given like this. HCH. These are the complex structures we are going to draw, right? First, I'll copy all the structures in the note, right? So I'll come up with the third one here. So yeah, I'll draw the third stuff here. CH2NO minus, no? NO minus, right? The third one. And its skeleton is given like this. Alright. So first quickly draw these three things. Okay. So these are few structures. Alright. So I'll copy the first one. This one. Right. I'm going to draw this Lewis structure. Right. Okay, I'm going to use this new technique without calculating the electron count. I'm going for this. Right. So in a Lewis structure, two main things are to be considered. Keep this in mind, clearly in mind. Right. Two things are, the octet should be there for these structures. For second row nonmetals, the carbon, nitrogen, and oxygens, the octets, the 4-pair situation should be there. Without octets, the structure is wrong. Without 4 pairs around the carbon, nitrogen, and oxygen, the structure is wrong. That is the first consideration. The second consideration is the summation of formal charges. The summation of formal charges, the charges on atoms, that summation should be equal to the charge indicated at the upper right corner of your species. Here the 0, here also 0, and here it should be -1. The summation of formal charges should be equal to -1. The formal charges means the charges on those atoms. Right? Those two things, keep it in mind. Those two things should be there with all the correct Lewis structures, acceptable Lewis structures. Right. Let's start with the first case, first one. Right? Now I am drawing Lewis structures or resonance structures. So resonance structures for the first one. For the first one, this thing, right? That is C(N2O2). C(N2O2), right? C(N2O2). Right. Let's do this one. Right. This is what I am doing. This is what I am doing. Because I'll tell you what I am supposed to do. Right. What I am doing here is, actually, I will start with one corner. I will start with one corner of the skeleton and complete those atoms one by one. Completing the atoms means I will come up with the octets, the 4-pair situation, as well as the charge of those atoms. That is how I am supposed to complete the atoms. Complete the atoms means giving the octets, the 4 pairs, and the charge. So I will complete the atoms one by one and come to the other corner. Come to the other corner. That is how I will complete this structure. You can start with this corner as well as this corner. For the first instance, I'll start with this corner. Right? Okay, this corner to this corner, I am drawing this, completing the atoms one by one. Right? Okay, let's do the stuff. The first structure. So first I'll draw the most stable structure. First I'll draw the most stable structure capable of this thing, right? So most stable structure means if you can draw a structure without charges on each and every atom, if you can draw a structure without charges on each and every atom, that would be the most stable structure. So I'll try to copy that. Without charges on each and every atom means your oxygen should have 2 bonds by completing the octets. The nitrogen should have 3 bonds. And carbon should have 4 bonds. Then those atoms are neutral. So if you can draw a structure like this, that would be the ideal, the most stable structure. I'll draw that. Right. So this is the structure. So oxygen, I draw the oxygen. This one. For a neutral oxygen should have 2 bonds. Complete the octet means 4 pairs should be there. So another 2 lone pairs are needed. So this oxygen is completed. One by one, I am writing the atoms. I am not supposed to erase any atom. I I am not supposed to erase anything. For with this technique, I am able to draw this Lewis structure in 10 seconds. So no need of erasing the stuff. If you think that you got wrong, right, just cut that structure with one single line and start draw it again from the beginning. Right? Don't erase. Because in 10 seconds we can complete this one. Right? Okay. So this oxygen is done. Now the second atom. For a neutral carbon, it should have 4 bonds. Already 2 bonds are written. For 4 bonds, you need another 2 bonds. Right? Okay. So no lone pairs are needed because 4 pairs are completed with that atom. Up to here, the structure done. Next, the nitrogen. For a neutral nitrogen, you need 3 bonds. Nitrogen, the magic number is 3. So already 2 is written, third bond. To complete the octet, you need 4 pairs around those atoms. So 1, 2, 3 is written, the 4th pair as the lone pair. So up to here, our structure is completed. The structure is completed. So now I am coming to the last 2 atoms. The last 2 atoms should be handled simultaneously. At once. That is the method. Until last 2 atoms, you are completing atom by atom. When it comes to last 2 atoms, do it simultaneously. Complete it simultaneously at once. Okay. So up to here, our structure was completed. So as we need the neutral charge, as we need 0 charges on each and every atom, right? How many bonds should I need to write here? How many bonds? So see how many bonds. So if nitrogen is with 3 bonds, it will become 0, and oxygen is with 2 bonds, it will become 0. So number of bonds needed here is actually 2 bonds. Then both the terms are neutral. So don't forget to complete the octets. So 1, 2, 3, only 3 pairs are going around the nitrogen. The 4th should be written as a lone pair, and around oxygen only 2 pairs are going now. So 3rd and 4th pairs should be added as lone pairs. So this is the most stable structure you can draw. Very easy. Very easily written. So you can come in as the most stable. Right? So if you are to think of, right, starting the structure with this side, still you can do this thing. No worries. You can write the same thing even by starting from this corner. Starting from that corner, here to here, still you can complete this. I'll do so. I'll do that as well. Right? I'll erase this one and I'll show you that you can do the same by starting with this corner as well. Right? For that instance, I'm going to erase this one and I will draw the same structure starting from this corner as well. See that I am capable of doing so. Right? If you are looking for the most stable, yes, we are looking for a structure with least charges on atoms. So if it is a structure with 0 charge, total net charge is 0, it is better to come up with all the atoms without charges. That is our main expectation. Let's start from this corner and complete atom by atom to come to here. See, right? Okay, I'm starting, right? So I'm writing this oxygen, right? For a neutral oxygen, you need 2 bonds. For complete octet, you need to come up with 2 lone pairs, 4 pair situation, the octet. My structure is done up to here. Then I am writing the next atom, nitrogen. For a neutral nitrogen, I need 3 bonds. 1, 2, 3. I need 3 bonds. Don't forget the octet. Don't forget the octet. Octet means 4 pairs should be there around the atom. 1, 2, 3 is written. The 4th pair as a lone pair. So my structure is done up to here. Up to here, the thing is done. Then the next atom. For a neutral nitrogen, you need 3 bonds. So 1 is here, 2, 3. So we are not supposed to erase anything. If you are written something, that's it. You can't erase. If you think like that is not going to give the structure, then cut it from one single line and try to draw. Start it again. Right. So for the octet, only 3 is written. 4th pair is needed. That is as a lone pair. Now my structure is done up to here. Final 2. I am coming to the final 2. Last 2 atoms. So I have to struggle that 2 things at once. Handle that 2 things at once. So I just put those 2 guys. Then I need to have these 2 with a 0 charge situation. So for a neutral carbon, 0 carbon, you need 4 bonds. For a neutral oxygen, you need 2 bonds. So if you are to come up with 2 bonds here, that will fulfill both the requirements. So this is octet okay for this one. Only 2 pairs are going around. So 3rd and 4th pairs should be written as lone pairs. So this is the structure. So you see, still we can draw the structure in no time, right? Starting from this side as well, right? From any side you can start the structure. This is the most stable structure. This is the most stable structure. When they have asked you to draw resonance structures, you should be able to come up with more structures, more acceptable structures, more acceptable structures. Acceptable structures means the 2 conditions should be fulfilled. What are the 2? The octet should be there with the second order non-metals. The 4 pairs should be there with the second order non-metals. And the charges, the summation of charges, the formal charge should be equal to the charge indicated at the species. If those 2 requirements are fulfilled, the structure is acceptable. If one of those conditions are violated, then the structure is refused. Right now? So I have drawn the most stable structure. Then I am supposed to draw few more resonance structures, few more acceptable resonance structures. They could be stable or less stable or unstable. There could be some other resonance structures which could be stable, unstable or less stable. Right? Let's draw those things as well. I am going to draw a few more resonance structures for this one. Right. Okay. So I thought of coming up with a unstable structure. For instance, acceptable unstable structure. Acceptable means octet is there and the summation of formal charges are going to be equal to 0 here. Acceptable structure. And unstable structure. Unstable structure means there are reasons to the structure to become unstable. If you are with a positive charge on oxygen, it is unstable. If you are with 2 adjacent atoms with the same sign charges, then repulsions will occur and unstable. So with those reasonings, I will come up with an unstable structure. Right, let's try. So I'll start with this corner. Even with this corner, I can come up with an unstable structure. So I'll start with this corner. Both these corners can be used. I'm trying to draw unstable structure starting with this corner. Right, okay, let's draw. So for unstable structure, first I'll draw some oxygen with a positive charge. Positive charge oxygen means it should be with 3 bonds. 2 bonds with oxygen is neutral. 3 bonds means you have one excess of a bond than the neutral situation, that is +1 charge. So to complete the octet, you need to have a lone pair. You need to have a lone pair. Right? You need to have a lone pair. Then the next atom. Next atom is nitrogen. Next atom is nitrogen. Next atom is nitrogen. So I can't erase, right? So in my mind, right, as the summation of charges should be equal to 0, in my mind the calculation is there. So it is great to have a -1 charge. It is great to have a -1 charge now to neutralize the charge on oxygen. So if you have a -1 charge with some atom, you can neutralize the charges and then come up with a 0 charge situation. Then it is very easy to handle with the 0 charge atoms. But unfortunately, we can't erase anything we have written. Right? So I'm not going to erase anything. So to connect this nitrogen to the other atom here, I have to put a bond here like this. So no choice. I have to put that like that, right? So the nitrogen is also coming with a +1 charge. So I should make sure the rest of the atoms, the rest of the remaining atoms, these 3 guys, the summation of charges of these 3 guys should be equal to -2. I should make sure that the summation of charges of these 3 guys should be equal to -2. So let's give some minus charges to atoms. So the next atom, if your nitrogen is with 2 bonds, if your nitrogen is with less than 3 bonds, then your nitrogen is coming up with minus charges. So if you are with 2 bonds, then you are with a -1 charge. If you are with 2 bonds, then you are with a -1 charge, because for the nitrogen, the 3 bond situation is the neutral. 2 bonds means -1 charge. So to complete the octet, you need to come up with the lone pairs, the 4 pair situation. 2 is written, the other 2 should be written as lone pairs. Right? So I am now up to the last 2 atoms. So need to handle those 2 things simultaneously at once. So just write the last 2 atoms, oxygens and the carbon. Oxygen and the carbon. Now I should think of number of bonds here. Which the summation of these 2 guys should give -1. Then the net charge is okay with the charge indicated here. That should be there, right? For acceptable structure. Net charge the summation of formal charge should be okay with the net charge indicated at the species, right? So I should have come up with some bonds, number of bonds to here, right? So that these 2 guys should give a summation of -1 charge. So how many bonds are needed? So if you are come up with 2 bonds here, neutral, the oxygen is neutral and the carbon is with 3 bonds, means it is -1. 4 bonds with carbon means 0 charge. 1 less than the neutral situation means -1. 3 bonds. So don't forget to complete the octet. 1, 2, 3, the 4th pair for the carbon. Oxygen 1, 2 is there, 3rd and 4th pairs. So your structure is done. So it's a unstable structure. You can come up with more reasons. What are the reasons? Right? Reasons are positive charge on more solitary oxygen, and you can write the adjacent connected atoms are with same sign charges here as well as here. Are with same sign charges. See, it's unstable. It's unstable. Right? So, this is how we are supposed to draw structures, right? So, I can use the same logic. I am drawing more and more structures to get some familiar nature with this technique. Huh? So, you can try your own stuff as well. Right? See, I'm going to draw another one. I'll draw another one. See, I'll come up with another asteroid structure. This time, I thought of coming up with a good structure. I thought of coming up with a good structure. Good structure means a stable one, where the minus charge on oxygen and adjacently connected atoms are with some opposite charges, right? I thought of coming up with a structure like that. Let's draw kind of a structure. Again, starting with the right hand corner. First, I'll draw with some structures with right hand corner, starting with right hand corner. Then I'll draw some with left hand corner as well. So I can draw more structures like that, right? So with this technique, in no time we can draw more structures, right? See, another one. So always remember, you can't erase, and you have to start from a corner and complete atom one by one and end up with the other corner. That technique should be used, right? Okay, let's start. So again, another structure. So I'll start with a minus oxygen for a better structure. Minus oxygen means only with one bond. So to complete the octet, should have come up with some lone pairs. Done. So after writing this thing, I am thinking of giving a positive charge to the next atom. After writing this thing, I am thinking of giving a positive charge to the next atom, because to neutralize the charges written so far, because the net charge is neutral. Net charge neutral means, right, it is better to have that neutral situation earlier. Then we can come up with the neutral charge atoms easily, right? So I'll come up with the next atom and try to give some positive charge to that. For this nitrogen, I can give a positive charge if it is with 4 bonds. Nitrogen with 4 bonds is positive. Now I am happy. Charge is 0. Charge tallies with the wanted stuff. Then what I should try is to keep the next few atoms with some 0 charge situation. That is what is in my mind, right? So next atom, I'm going with the next atom, third atom, the nitrogen. Unfortunately, I can't do so. Because I can't erase anything what I have written. So definitely this nitrogen comes with a charge, because I have to write a bond here to connect this nitrogen to the other atom. So nitrogen with 4 bonds is positive. So again I am coming to the last two have to handle at once simultaneously. So the carbon and oxygen, last two. So I should think of a way, right? I should come up with a way, right? Where these two guys, right, as a whole gives a -1 charge, because now the net charge is +1. We need some -1 charge from these two guys as a whole. So we can give that thing by just writing 2 bonds here. The oxygen is 0 and the carbon with 3 bonds is -1. So don't forget to complete the octets. For this carbon, 1, 2, 3 is written, the 4th pair, and for this oxygen, 2 is written, the 3rd and 4th pairs. Right? And this structure is also considered as unstable, because these two atoms are with same sign charges. So even though I was thinking of drawing a stable structure, but unfortunately those two guys were with same sign charges, the nearly connected atoms, right? So it is unstable, right? So this is kind of unstable structure, as these two guys are with same sign charges. Adjacently connected atoms. Right? So I have drawn 3 structures. We can draw few more. I can draw few more. I can start this oxygen bearing a minus charge. I can start from this oxygen bearing -1 charge and come towards here. So I can draw few more structures. Let's draw another one like that. See? Another structure. Right? Starting with this oxygen bearing -1 charge. Right? See? Bearing -1 charge. -1 charge means only 1 bond should be there to complete the octet. 3 lone pairs should be there, 4 pair situation. The next setup, I am thinking of giving a positive charge as soon as possible to maintain the 0 situation. But unfortunately, carbon can't have a positive charge in your Lewis structures. I already said that. To carbon to have a positive charge in Lewis structures, you should have 4 plus 1 bonds, 5 number of bonds. That is not allowed with the octet rule. 5 pairs can't be there around the second non-metals. Right? So I can't give that plus charge to the carbon. So I will keep it with a 0 charge. I'm not going to give it any minus charges. Then my task will be a bit harder. Right? The summation of charges should be 0. No? So I'm not going to give you the -1 charges. Right? So I'm trying to give some positive charges as soon as possible. Next atom, it is nitrogen. So to connect that atom to the other atom, nitrogen needs 4 bonds so that it is become a positive charge. Come up with a positive charge. So now I am happy. Now I am happy because the charges are now neutral up to now. So that is what we need. So I am coming up to the final 2 atoms. Have to handle at once. So I need to keep these 2 guys with a neutral charge, with a 0 charge. Right? Then the summation of charges will be equal to 0. So we can do so by writing 2 bonds here. The nitrogen needs 3 bonds means it is neutral. The oxygen with 2 bonds means it is neutral. So don't forget to complete the octets, the 4 pair situation. 1 pair is needed here. 1, 2, the 3, 4. So this is kind of an acceptable structure and it is a stable structure. It's a stable structure. So oxygen bearing a negative charge, it is going to be a stable structure. It is not the most stable, but one can write it as a stable structure. No, it is less stable, no? Sorry for that. It is less stable, no? We have a reason to become less stable, no? No, high charge dispersion. Don't write it as stable, Lamai. It's a less stable structure. High charge dispersion. So we have to come up with step by step, no? The stability reasonings. So it is having a problem. High charge dispersion. More atoms with charges compared to the most stable structure you can draw. Compared to the most stable structure you can draw, you have more atoms with charges. It's a high charge dispersion situation or high charge distribution situation. So it is referred to as less stable. Less stable. So it is high charge distribution. distribution or dispersion, both are okay. When you are with more atoms with charges compared to the more stable structure, it is going to be less stable. So those are few structures we can draw for the same skeleton and for the same compound CN2O2, right? Those are few acceptable structures, right? So we can draw much more. You can even start with the positive charge here. You can start with the positive charge from here and draw some structures. So you can draw, right, a few more structures as well. Right? Actually, what we need to give you is the confidence that you can draw these structures like this, even without calculating the valence electron count. You can do so if you are doing the steps, right, correctly, starting with one corner to going towards the other corner. And if you are following these things correctly, yes, you can draw these structures in no time, right? So just try. Don't look at the board, the row. So two of you, yeah, just try whether you can draw the ones, right, without looking at the board. Just try whether you are able to come up with these same structures. By doing so, starting with this corner or this corner, you can start with a minus oxygen or plus oxygen even. Or for this most stable one, better to come up with the neutral charges for all the guys for the most stable thing, no? So you should look for the structure without charges with all the ones, right? So those things should be considered, right? So just try to draw a few more. To draw these things, just try whether you are able to do so by just not looking at the board. Right now, okay. So let's try to draw some resonance structures for this one as well, right? This is a bit strange structure, not like this, right? Because you see, this is just a linear one. No things are there like this. So here you clearly see some hydrogens are appearing. Other than the second one unbalanced, the hydrogens are also appearing, and not a linear chain like this. So let's try to apply the same rules, same theories to come up with this kind of structure, right? To come up with this kind of a structure, let's try to apply the same rules. So after you writing those structures, always just check atom by atom, just check whether the octet is there. How to check the octets? Just calculate the pairs around those atoms. See, 1, 2, 3, 4. 4 pairs are there, octet is okay. 1, 2, 3, 4. 4 pairs are there, octet is okay. 1, 2, 3, 4. 4 pairs are there, octet is okay. 1, 2, 3, 4. 4 pairs around the nitrogen, octet is okay. 1, 2, 3, 4. Always after writing the structure, just count the octets for those atoms. Second one is carbon, nitrogen, oxygen. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Octet means 4 pairs around those atoms. 1, 2, 3, 4. Done. 1, 2, 3, 4. Done. So just do those. Then that criteria is okay. Then get the summation of the charges on the atoms, formal charges, and that should be equal to the charge indicated here. So do those two checks. Check those two things. Right? If those are okay, then your structure is acceptable. right now. That is how we mark those structures in our paper marking stuff, right? When we are doing the paper marking, it is how we are marking those things, right? We are looking around the octets of those second order unpills. Then we are calculating charges on atoms, and that should be equal to the charge indicated at the upper right corner of the chemical formula, right? Okay, let's draw some few resonance structures for this one, the second stuff, right? So you can draw 5 or 6 stuff, right, like this. Right, so let's come up with the second thing, C2H2N2O, right? Okay. So it is very easy, yeah? Drawing complex fluid structures, even though it looks like complex. I think this is more easier than the earlier situation, than the counting the valence electrons, that method, right? So let's come up with the second example. Right. Right. Let's draw some resonance structures for your second example at page number 16. Right. Now I am going to draw some resonance structures for this thing. Huh? Resonance structures for 2. C2H2N2O. Right. Let's draw. The only thing I need to tell you here is actually, so when you are dealing with this stuff, with these hydrogens, the stuff containing the hydrogens, right? Consider this whole thing as a one. Consider this whole thing as a one single group. Then it will be very easy to do this stuff. See how I am supposed to come up with that. It's like this. So I am first trying to draw the most stable structure. I'll draw the most stable structure possible with this thing. Right, I'll start drawing from this corner. Right, I'm trying to draw the most stable structure. After that, I'll do the same with this corner as well, no? Right, okay, right. So let's start with this corner. So for this most stable structure, if you can come up with a structure with all the atoms with 0 charges, that would be the most stable structure. So first of all, I am trying to draw that thing. So I am starting my drawing with this corner. So atom by atom, I am trying to complete that thing towards here, right? Okay. So let's start. So this atom oxygen is written. So for a neutral oxygen, you should have 2 bonded pairs. Right? So for the octet, should have 4 pairs. So that is written. Now I am done with that oxygen. Next atom, the carbon. For a neutral carbon, you should have 4 pairs. 4 bonded pairs. So already 2 is written. Third, fourth. Done. That carbon is done. Next atom, the nitrogen. For a neutral nitrogen, you need 3 bonded pairs. 3 bonded pairs. 3 bonds. So it is neutral. Don't forget the octet. 1, 2, 3, the 4th pair as a lone pair. So up to here the structure is done. Up to here the structure is done. So I am coming to the last 2 atoms now. So I consider this one as a one group, as a one atom. I consider this whole stuff as a one atom. Always we are considering on second order nucleus, right? So these 2 guys are carried by the carbon. So I consider this whole thing as a one atom. So now I am up to the last 2. I must do up to the last 2. This one and this one, last 2. So those 2 things should be handled at once. So this nitrogen and this carbon. See this. This is very important. Nah? The carbon. Last 2. Nitrogen, carbon counts as a group. Right. So I need to come up with 0 charge at this whole section. This thing should be 0. Because these are 0. So to handle the charge, as the net charge should be 0. So here I need to come up with some bonds. Right, which will be okay with 0 charge for these 2 guys. So if you are to put 2 bonds here, carbon with 4 bonds neutral, nitrogen with 3 bonds neutral, I am done. Right, don't forget the octet. So nitrogen is 1, 2, 3 with 3 bonds. So 3 pairs. The 4th pair is this. So that is your most stable structure. That is your most stable structure. That is your most stable structure. Where no atoms are with charges. See, I have just drawn that thing starting from this corner. Right? We can draw the same thing. We can draw the same thing by starting with this corner as well. From starting with this corner as well, we can draw the same thing. Right? I'll do that as well. I'll do that as well. To give you some confidence about this technique, I'll do that as well. Right? This can be done very easily. 10 seconds now. Yes, in 10 seconds, we have completed the structure. Right? Okay. So, I'll write the same thing starting from the other corner, this corner. Right? See? For the most stable structure. So you can start with any corner, right? No worries. If you think that it is not going to happen, give you the structure, then cut it by one line and just start with the other corner. No worries, right? So various techniques are various combinations are available. No worries, no? Right? Okay. So let's start from this corner. So I'm going to try the most stable structure, starting with this corner. Right? So the first thing to draw, this section is handled at once, right? So I'm starting with that, this section. Okay, right. Okay, then for this guy to be neutral, there should be 4 bonds around that carbon. So I'll just write the 4 bonds. That is done. So I need to keep all the atoms with 0 charge for the most stable species, right? Okay. Next atom, nitrogen. So for that nitrogen to become 0 with a neutral charge, it needs 3 bonds. 1, 2, 3. So lone pair should be added as octet should be fulfilled. 4 pairs should be carried out. Next atom, next nitrogen. To be as a neutral nitrogen, it needs 3 bonds. 1 is written already. 2, 3. Octet completion. I am up to the last 2 atoms. C and O, the last 2 atoms should be handled at once. So I should have come up with some number of bonds where these 2 are giving you a net charge of 0. So that how many bonds are needed here? So if the carbon is with 4 bonds, it's neutral. The oxygen is with 2 bonds, it's neutral. So you need to come up with 2 bonds here. So don't forget to give the octets. So carbon is with 4 bonds, 4 pairs, that is octet. And oxygen is with only 2 pairs around it. Third and fourth pairs should be added as lone pairs. So it is neutral. So this is the most stable structure you can draw. Very easy. Even starting from this side or this side, I have drawn the same structure. Right? So what you should have is the confidence that you can do so. So just try. Just do your work at home. Right? Get this confidence. From the left hand corner or the right hand corner, from any corner I can start. I can start with a positive oxygen, negative oxygen. I can start with a positive atom, negative atom. Still we can complete the structure. Complete a resonance structure. A stable one, unstable one, less stable one. No? Let's try to come up with a few more resonance structures for this compound 2. Right? Let's try to come up with a few more. So I'll try to draw a structure giving some positive charge to this oxygen. So I'm going to try to draw some unstable structure starting with positive oxygen. Let's draw. So I'm starting with a positive oxygen. Positive oxygen means should have 3 bonds. Oxygen with 2 bonds is 0. 1 excess of a bond is +1. So I am looking of a atom with -1 charge now, because net charge is 0. I am thinking of a atom with -1 charge to neutralize this positive charge to come up as 0 net charge. That is my main consideration running in my head now. Right? But unfortunately, I can't erase anything I have written. So I am coming with the second atom. So it is this carbon. So it is needed to connect to another one. So carbon is neutral. I can't come up with a negative carbon here because already I have written 3 bonds here. For a negative carbon only it should have 3 bonds. But now 4 bonds are there. So I am thinking of giving the -1 charge, -1 charge to the next atom possible. Next atom, soon as possible. Right? Let's come up with the next one. Next atom is nitrogen. So yes, I am happy. I can give that minus charge to nitrogen. If nitrogen is with 2 bonds, it is minus. Nitrogen carrying 3 bonds means neutral. 2 bonds with nitrogen means it's -1. So don't forget the octet. 4 pair situation 1, 2, 3, 4. Completing atom by atom. Now I am up to the last 2 atoms. I am done with this, and I am up to the last 2 atoms. This one and this. So just handle it at once. This is the situation. Last 2 atoms, right? Right now. Last 2 atoms. So the charges, net charge of these things should be 0. Then we are done, because net charge should be 0. No? So these 2 guys carry 0. Then net charge should be 0 with this section as well. Then net charge is going to be 0. So it is okay. So how many bonds we need here? So if you have to put 2 bonds here, the carbon is with 4 bonds, 0 charge. 3 bonds with nitrogen, it's 0. That is done. Don't forget the octet. Put the lone pair there for the 4 pair solution with this nitrogen. So this is an acceptable structure where the octets are fulfilled with all the second order nonmetals, and the summation of its charges are equal to the charge of the species, 0 here. So this is acceptable structure. Anyway, it is unstable. It is unstable as oxygen carrying a positive charge on it. Unstable structure. positive charge on most reactivity oxygen. Right now? Let's draw another one. You can draw more structures, huh? So let's draw another one. I have started with 0 here. I have started with positive oxygen here. Let's start with a negative oxygen as well. Why not? Why not? Start with a negative oxygen as well at this code. Right? Just try. Just try. Normally in A levels, they will ask you to draw 3 resonance structures. Only 3. The most stable and another 2. Right? So even we can draw far more structures, right? We can draw 5, 6 resonance structures for this one. Right? Okay. Let's draw the stuff. So let's start with the minus with this oxygen. Let's start with the minus with this oxygen. While I am doing so, just try. You can draw these ones. No need to look at the board. After writing the stuff, you can check those. Check for the octets of the second order nonmetals. 4 pairs around those. Then check the summation of charges. Should be equal to the charge indicated at the upper right corner of the chemical species. You can check those stuff. And even you can send those pictures to me. I'll correct. If you have written those structures, don't look at the board and write, right? Just draw and comment and then send it to me. Send those to me. Right? I'll correct. You can correct those things on your own, right? But if you feel not that much confidence to correct the structures, send it to me. Right? Okay, let's draw another one. Starting with a minus from this side. Right? Okay. See, I'm starting with a minus oxygen, na? Right. Minus oxygen means 1 bond with oxygen. So 3 lone pairs should appear as to complete the octet. It's minus oxygen. So I'm thinking of giving a positive charge as soon as possible. I'm thinking of giving a positive charge as soon as possible to come up with the charge of the species. Come up with the charge of the species, right? Okay. So with the carbons, you can't. With the carbons, you can't give positive charges. Carbons can't bear positive charges, right? I earlier said also, right? So carbon can't bear positive charges, right? So don't try to give positive charges for carbons, right? So carbon is neutral with 4 bonds. If the carbon needs to achieve a positive charge, it should have 5 bonds, 5 numerous bonds. That can't be, no. That can't be, right? So octet, no. Second order nonmetals, no. Can't exceed the octet for second order nonmetals, no. So that can't be. So so that let's come up with 0 carbon. Let's come up with 0 carbon. Don't give the carbon a -1, right? Okay. Don't give the carbon a -1, right? So then you are right going away from the net charge. Then you are going away from net charge here. Don't try to give a another minus, right? Always try to be in the vicinity of the net charge, right? Close to the net charge. Always try to stay safe with closer to the net charge. It is 0 here. Don't go away from the net charge, right? By giving a minus charge to the carbon, right? So it's 0. Better to have 0 there, as carbon can't have a positive charge. Then the next atom. So I am happy. I can give the positive charge to the next atom, the nitrogen. Okay. Now the charges are 0. The summation of charges equals 0 now. Right? Okay. So I am now up to last 2 atoms. So just write the 2 atoms, the nitrogen and carbon, last 2 atoms. So I need to come up with some 0 charge with this section, right? Because the already charges are balanced to this number. So to come up with 0 charges with all these guys, right? Better to put 2 bonds here. Nitrogen with 3 bonds is 0. Carbon with 4 bonds is 0. So don't forget the octet of this one. 4 pair situation. Need to have a lone pair here. So the 4 bonds are complete with this nitrogen as well. So this is a good acceptable structure. Acceptable structure. And we can consider this one is as a less stable structure because we can draw a structure without charges on each and every atoms. Without charges on each and every atom, we can draw a structure. So that we have to mark this as a less stable. Less stable because you have more atoms with charges compared to the more stable structure. So that it is less stable. Right? The comment is less stable. The reason is high charge dispersion, high charge distribution. Both are same, right? This comment will be written when you have more atoms with charges compared to the more stable structure. High charge distribution or high charge dispersion. Right, no? So I have started with 0 oxygen here. I have started with a positive oxygen here. I have started with a negative oxygen here. Still, I was able to draw structures. Right? Okay. Then let's start with a negative carbon here. Let's try that as well. Negative carbon here. Why not? I have tried with 0 carbon here. I can't have positive carbons in Lewis structures. Then we'll try with a negative carbon as well here and go towards the to come up with the acceptable structure. Let's try. Let's try. This was the most stable one, no? This was the most stable one. So I am trying to draw another acceptable structure, right? By starting from here as a negative carbon. Let's draw that stuff. Right. Negative carbon. See. So that thing will be written like this as a whole, the first atom, right? So I am starting with the negative carbon. So negative charge means for this carbon should have only 3 bonds. If carbon is with 4 bonds, it is 0. 3 bonds minus 1. Carbon is with 3 bonds, right? So to complete the octet should have a lone pair. This is the negative carbon. So I have started with the negative carbon. So in my mind, I am thinking of giving the next possible atom, the next nearest atom, a positive charge. Right? If I can give a positive charge to the next atom, then I am happy because I am okay with the charge then. Right? The next atom is nitrogen. So I can give that positive charge to that thing as it is able to come up with 4 bonds. Nitrogen with 3 bonds is 0, 4 bonds is plus 1. So now I am happy. Now I am okay with the charge. So now what I need to do is just come up with neutral charges on all of these atoms, all of remaining atoms. If I can come up with the neutral charges with those, then that is what required. But unfortunately I can't erase anything I have written. So that the next nitrogen comes with a positive charge. Because we need to connect that nitrogen to that other atoms now. So definitely nitrogen comes with 4 bonds, so it comes with a positive charge. Now I am up to the last two. I have to handle those 2 things at once simultaneously. So when it comes to these 2 guys, as now I am with a net charges plus 1, these 2 guys should carry some minus 1. No? These 2 guys should carry some minus 1. Because as I am with a net charge of plus 1 up to here, these 2 things should carry minus 1 as a whole. Right. What I can do? Right, if you are coming up with 2 bonds here, definitely oxygen carry no charge with 2 bonds. but with 3 bonds, the carbon will carry -1. So I am happy. Right? Don't forget to complete the octets. 4 bond situation, right? 4 pair situation, sorry, 4 pair situation. So 1, 2, 3, the fourth. With oxygen, 2 pairs are there, the third and fourth pairs, the octet. So this is referred to as a unstable structure because the adjacent connected atoms are with same sign charges. Unstable at structure as adjacently connected atoms are with same signed charges. Right now? That is the fourth structure you can draw. You can think of furthermore, Lamai, right? You can start up with something like this and try to give some positive charge here. Then think of some negative charge appearing at there to neutralize the charge. And you can draw like this, that as well. Right? So, try to draw these ones. Try to draw these one things as in your own, right? So that is how we're supposed to draw some Lewis structures, huh? Complete Lewis structures in no time. Just do. Right? Don't look at the board, Lamai. Just do it your own, right? Then see whether you are capable of doing this stuff. Right? You can send those answers as well to me. Even now, if you have some capability of doing so, just send me the answers, right? I can correct. Right? If not, you can send the answers afterwards. Right? Okay. Don't look at the board and write, right? Just write it in your own, right? So let's see. Right. Let's draw this one as well. Okay. After writing these things, so you can take a screen capture here, right? If you need, right? So I'll send you the video as well, no? Right. Okay. Just send me the answers now, yeah? Just send me the answers. Then I can correct, right? Anyway, for a accidental Lewis structure, the two considerations are the octet should be there with the second one non-metals, the 4 pairs situation, and the summation of charges should be equal to the charge integrated at the upper right corner of the species, right? If those two are okay, that's actually acceptable, right? Okay, let's do this one. Some structure with a charge, not third. Some structure which is a charge, right? The net charge should be -1. So same logics are applied. And the net charge should be -1, right? That's all. Let's do some resonance structures for these things as well. Right. Okay. I come with those, right? Okay. Now don't try to copy the board, right? I will definitely give you the video. I will definitely send you the recordings, right? So don't try to copy the board. Just try to write in your own, with your own, right? So you can check those things when the video is there, right? No worries, no? Or you can send me the answers, right? Okay. So anyway, you should have the skill, right? You should gain the skill, right? Drawing Lewis structure alone, right? Okay. Let's come up with a charge structure. No worries, right? Not hard. The same things to be applied, right? The net charge is going to be -1. That's all. For the structure tree, right? So I'm going to draw the structure tree, yeah. So my next consideration is to draw this one. Right? So again, these things are studied at once, right? Taking as a whole is the H2 group. Right. Let's draw some resonance structures. The most stable ones and the others, right? The stable, unstable ones for that structure tree. For third structure. The CH2NO minus. Right. Let's try to draw these ones, right? Let's start. Right. So again, I'll start with, first I'll start with this corner. Afterward, I'll start with this corner as well. Okay, let's start with this corner because I thought of drawing the most stable structure, right? So for the most stable structure, negative should appear on the oxygen. That is better. Appearance of the negative charge on the most electronegative oxygen is the best one. So I'll start with that. Negative charge on this thing. I'll draw a structure like that. Then I try to draw some most resonance structures by starting with this carbon as well, right? First, I'm going to start with this because I'm looking for the most stable structure. For the most stable structure, it is better to have the negative charge on the most electronegative atom, right? That is why I'm starting with this, right? Giving it a minus charge, right? Okay, this is the most stable I am trying to draw, right? So giving a minus charge to oxygen, so that means it should have only a single bond. Minus charge to oxygen means it should have only one bond. 2 bonds with oxygen means neutral. 1 bond with oxygen means -1. So to complete in the octet, right? So the next atom. So my plan is to keep all the other atoms at the neutral position. My plan is to keep all the atoms with their neutral positions, neutral situations. Then I would think of a most stable structure. Only one atom carrying the charge, and that is also on the oxygen. So all the other atoms are without charges. So that would be the best structure. That is our main consideration, first of all, right? Drawing the most stable structure, right? Okay. So now I am trying to keep all the other atoms with a neutral position, right? So nitrogen is neutral when it is with three bonds. This is 3 bonds, right? Don't forget the octet, the 4 pairs, 1, 2, 3. The 4th pair should be long, right? I am now up to the last two atoms. I'm now up to the last 2 atoms. So last 2 like this. Last 2 atoms. Right? So I need to keep these things with some neutral, 0 charges, to come up with the net charge as -1. So how many bonds needed here? It is 2 bonds. With 2 bonds, right, this carbon will come up with 4 bonds, that is neutral. This carbon will also come up with 4 bonds, that is neutral. So this is the best structure we can draw, right? This is the most stable structure we can draw. Right? So for a structure with charges, you need to come up with a comment. At these structures, I haven't written any comment for the most stable structure because you don't have charges there. But when you have a most stable structure with the charges, so we need to come up with the reasons why you select that as the most stable structure, because there's a negative charge on the oxygen. negative charge on most retentive oxygen. Right? So that is the most stable structure. Let's draw a few more. Right? I started with here the negative charge. I start with here the negative charge as well. I start with this cone as well with the negative charge to this carbon. Let's start. Why I can't? Right? So, right, I'll give some minus charge to this carbon. For a minus carbon, should have only 3 bonds. 4 bonds means 0 for carbon. 3 bonds means -1. So, to complete the octet, should have a lone pair, the 4-pair situation. Right, the next atom is carbon. So, my plan is to leave all the other atoms at the neutral position. My plan is to leave all the other atoms at the neutral position, so that the net charge is going to be equal to the summation of the charges should be equal to this one, right? So it will happen, right? If I am to leave all the other atoms at the 0 position. So to have a 0 charge with this carbon, it is better to have 4 bonds with that. So it is 0, right? So I am coming up to the last 2 atoms. So have to handle at once, right? So what should happen, right? With these 2 guys, the net charge should be what? The net charge should be 0, no? Net charge should be 0. For these 2 atoms, the net charge should be 0. If the net charge should be 0 with these 2 atoms, the total charge is going to be -1. Let's try this with this one, right? Okay. To have a 0 net charge among these 2 atoms, right? You can come with only single bond here. A single bond here means nitrogen with 4 bonds is +1. Oxygen with 1 bond, it is -1. So net charge is 0. So altogether charge is -1. So we are happy. So don't forget to keep the octet with the guys, right? 4 pairs are there around the nitrogen, that is OG. With this oxygen, only 1 pair is there. Second, third and fourth pairs should be written as lone pairs, right? So that is done. Right? So another acceptable structure, and it can be taken as a less stable structure. Because high charge distribution, right? More atoms with charges compared to the most stable structure. Compared to most stable structure, you have more atoms with charges. So less stable. The reason is high charge distribution or high charge dispersion. Right now. Right. Let's draw another one. So I have started with a minus from here as well as from here. So I am not supposed to come up with a positive charge. I am not trying to come up with a positive charge from here or from here, right? Because that is not good. So the charge is -1 now. I'm always like to stay around that charge. The -1 means I'm like to stay around that charge. 0, this no. So -1 means net charge will be -1 no. Right? So I'm always trying to stay around that thing. The 0 and the -2 are okay. I'm not going to go far away from that -1 charge. I'm not going to go far away from that -1 charge. Right? This -1 charge is there, no? So -2, 0, between that, I'm trying to stay, right? Because if not, it will be hard to come up with the charge indicator here. So I'm not trying to give some +1s, start with +1s here or here, right? It's not good. Even though we are capable of drawing such structures, we can do so. But for first considerations, I'm not going for those, right? As those are a bit hard to draw. Some more possibilities there for our structure to become wrong, right? Okay. So let's try to come up with a neutral charge here. Start with a neutral charge here, and we'll give some a negative charge to some other atom. See, that is another way of writing, right? So I'll start with a 0 charge with this carbon. It's a 0 charge with this carbon, right? Then I'll give some that negative charge to the next possible atom. Then I'll keep the other atoms at a neutral position. Right? So that is my plan here. So it's neutral, so I'll give the minus charge to this carbon. Carbon with 3 bonds is minus. So to complete the octet, need a pair. Right? And now up to the last 2 atoms, the N and O. So the summation here should be 0. Then the total structure carries -1. So have a 0 charge between these two guys as a net. So better to come up with 2 bonds here. Nitrogen with 3 bonds is 0. Oxygen with 2 bonds is 0. So I am done. So don't forget to come up with the octets. That is 4 pairs should be there around nitrogen and oxygen. 1, 2, 3, the 4th pair. Oxygen 1, 2, 3, 4. Right now? So another acceptable structure. Right? So there's no reason to become unstable here or less stable here. There's no reason to become less stable or unstable here. Just then we can take it as a stable structure. It's not the most stable. For the most stable structure, better to have the negative charge on the most secondary atom, the oxygen. But it's not the most stable, but you don't have any reason to become unstable or less stable. So then we have to consider it as a stable structure. Right now? So such structures can be written. Right? Okay. Right? Few more can be drawn. Let's draw another one with the same logic. What I have done here is actually we started with a neutral atom and then gave that minus atom to the next possible. Right? Let's do the same thing with this side as well. Let's try to do. So that we would be able to come up with another new structure, resonance structure. See? Let's try. This oxygen, I am keeping it at a 0 stage. Complete the octet. I am trying to give the next possible atom the minus charge. But unfortunately, for this nitrogen, I can't do so. When nitrogen connects to the other atom, it is coming up with 3 bonds. So that is neutral. So then, I am coming to the last 2 atoms. No worries, we can do so. Don't worry. Until the last atom. Right? We should try. Okay. Now, what is the concern? Concern is between these atoms, the -1 charge should be there to come up with the net charge. So that the only possibility is coming up with 2 bonds here. So that this is neutral and this comes with a -1 charge. Unfortunately, that is the same structure as the earlier one. Right? So that technique also given you the same structure as the earlier case. Right? So that is not going to B, right? That's not possible then. We are not writing the same stuff twice, no? Right? So these are the 3 possible Lewis structures we can draw for this molecule. Now, if you are thinking of, if you are very comfortable enough with this technique, you can try for some harder cases as well. You can try with a positive one with oxygen as well. You can try. Let's try that stuff, right? This is just a game, Lama. Just a game. What you need is actually to confidence with this technique. Let's try. Okay, let's try. Whether we are able to do so, right? Whether we are able to come up with a positive charge and do the stuff. Let's try. These are kind of hard stuff. More possibilities there to come up with a wrong answer. But let's try for our confidence. Right? So I'm starting with a +1 here. That is not, right, normally a way to come up with, because I'm not, normally we are not saying you to go far away from the charge needed, right? But let's try for our confidence, right? So next atom, it is also coming up with a positive charge. So now the thing is very hard. So then the last 2 atoms should come up with -3, yeah? Last 2 atoms should come up with -3. So this task is very hard now. Should come with -3. Right? Game is not over yet. Right? Just try till the last blood, right? Okay. Can't we? Yes, I see. We can do so. Yes, if you are coming with only 1 bond here, see, this carbon with 2 bonds carry -2. This carbon with 1 bond, 3 bonds carry -1. So I am happy. We are done. Still we are able to do so. See, complete the octets. 4 pairs. See, what we need is just the confidence, Lamai. What we need is just the confidence. Right? So again we had come up with a accelerated structure where the octets are fulfilled and the net charges are equal to the formal charges are equal to the summation is equal to the net charge indicated there. So this is kind of a unstable structure. Few reasons to become unstable. Anyway, it's an acceptable structure. Octets completed and summation of charges giving you the net charge. Summation of formal charges giving you the net charge of the species, right? So reasons to become unstable is positive charge on more acidity in oxygen, right? Oxygen. And the second point is adjacently connected atoms are with same sign charges here as well. With same sign charges. Right now? So that is about that. The third structure. Right now? So just try, Lama. Just try whether you can do so. After that we'll do the next one as well. The fourth exercise. I'll send you some homework, Lama. I'll send you some homework as well. So we'll complete all the 4 structures at the page number 16. So some practice is needed, right? To do at home. Also, I'll send you some work right now. just draw some few structures. So I'll give you some 5 minutes to draw some structures for the fourth case as well. So just draw 3 resonance structures, the most stable structure and 2 more. The most stable structure and 2 more for the fourth structure given in your tute. For the fourth skeleton given in your tute, just draw some 3 resonance structures and comment on their stabilities as well. The thing is C2H no, yeah, the fourth stiff, right? Skeleton is given like this now. Just try this structure as well. So when you are trying Lama, you just take this whole thing as a one, right? That is the way of doing the stuff, right? Take this whole thing as a one. So for a linear chain, if something are there, right? So just take that whole thing as a one. Then it would be easy to handle. Right. I'll write this. Right? Actually, in 10 seconds, you should be able to draw this stuff. Okay. So, in A-level paper, there will be a kind of maybe 8 to 10 Lewis structures. There will be 8 to 10 Lewis structures to draw in A-level paper. I mean, in the first question, the structured first question, there will be most probably 8 to 10 Lewis structures to draw. but they are giving you only 15 minutes. In 15 minutes, there will be 8 to 10 Lewis structure draw. Some more other stuff are to be done, right? Not only drawing the Lewis structures, they are the question, right? So some more stuff are there. So to draw those 10 to 8 to 10 Lewis structures, you can consume only 5 minutes. You can't consume more than, even 5 minutes can't be consumed. You can take only 3-4 minutes maximum, right? So basically this kind of structure can be drawn even in 10 seconds, right? So that speed is needed. That is why we are going for this kind of a method rather than doing the electron count and stuff, right? Okay, so let's draw some axial structures for this one. C2H2, no? That is structure, no? Yeah. Let's draw. So I'll start with this cone. Right? For a more stable structure, better to have zero charge atoms with all the stuff, right? So let's try with that, right? So with this cone, right? For neutron nitrogen, you should have 3 bonds, right? 3 bonds. For the octet is completed by giving it a lone pair. Then the carbon should have 4 bonds for it to be a neutral one, right? Then last 2 things, no? Yeah. Last 2 things to handle, right? So this is oxygen, na? This is oxygen. So even we can handle this one clearly, you know. So yes, as it's oxygen, better to take these 2 as the last 2, no? Yeah. So take this one as whole, right? It's better. This is just oxygen. Okay. Right. Okay. Take that 2. So this is going to be the last 2. These 2 going to be the last 2. Better take this one as whole. This is hydrogen, no? This is not like that, right? Okay. So take these 2 as last 2, right? So you can take one single bond here, right? So these are the last 2 guys. So for a neutral situation, best to come up with 4 bonds of carbon and 2 bonds with oxygen. So some pair here. So this is the most stable structure you can draw. And don't forget to give the octet. Right now. Okay. Right. This is the most stable structure, right? Few more structures. So I could think of starting with some negative charge here. Let's start with some this cone with some negative charge. This cone with some negative charge. So some negative charge with that cone. So only with 1 bond that appears, the negative charge appears. Then we have to handle these 2 guys together, right? Okay, ZH things, right? So this carbon should have 4 bonds. So you can't give a positive charge to the carbon, no? To become neutral, you can't put a positive charge to the carbon, no? So my mind, I'm always thinking of giving a positive charge to the next nearest atom, right? But it can't be given to the carbon. Carbon can't come with a positive charge in Lewis structures exceeding the 4 pair situation, right? So carbon should be kept in a neutral situation like this. So next atom means oxygen. So oxygen with 3 bonds will come up with the positive charge. So complete the octet, giving the lone pair. Now I am up to the last 2 atoms. So this one and last 2 atoms. So net charge here should be 0. to come up with the charge here. As the charge is 0, this should be 0. So that can be done by giving 3 bonded pairs here, 3 bonds there. So don't forget the octet of this one, right? 4th pair. So this is kind of a structure which is known as an unstable structure. Why is that? Because you have positive charge on oxygen. Positive charge on most electronegative oxygen. Right. Can we draw few more? Can we draw few more? Right. Let's try like this. Let's try like this. So we have started with minus from here, this side. Let's started with some minus from this side as well. This side. Why can't we? We have started the neutral here. We have started with the minus here. Let's start with the minus here as well. Right? Let's start with the minus here as well. Right? Let's start that thing with the minus here. So nitrogen with 2 bonds coming up with the minus. Right? Our next task is to, our next constraint is to give a positive charge as soon as possible to neutralize to come up with the match the charge here. So, but unfortunately, you can't give the positive charge to the carbon. You can't give the positive charge to the carbon, right? Carbon won't have don't carry positive charges in Lewis structures, right? Then the next setup, oxygen. Yes, we can give the positive charge to oxygen then. Oxygen with 3 bonds, it's positive. Don't forget to give the octet. 4 pair situation. So now we are up to the final 2 atoms. Final 2 atoms. This and this. Right? Final 2 atoms. This thing and this. So what should happen? With these guys, we should maintain some. Sorry, here is positive now. 3 bonds is positive now. Sorry. Right? So with this part, we should maintain some 0 charge, no? 0 charge. So to match this charge here, as this is up to here, the charge is 0. So this should also carry 0 charge as a net, right? So we can come up with the 0 charge if you have to put some double bond here. So carbon uses 4 bonds, 0. Oxygen is 2 bonds, 0. Don't forget the octet of the oxygen, 4 pair situation. Right now? So that is also acceptable structure. So net charges, the summation of net charges is equal to the charge indicated here, and the octets are fulfilled with all the second order non-metals, right? So this is a acceptable structure, and this is also unstable due to the same reason here. Bearing positive charge. Positive charge on most electronic oxygen. Right now? Okay. So those are the possible resonance structures for that molecule. Possible resonance structures. Right now? You can try for few more, right, at home, right? So I'll give you some homework, right? I'll send you some more skeletons. So I will give you some more skeletons, right, to do the resonance structures as well, to practice at home, right? Okay, this is all about complex Lewis structures, right? We had just drawn in no time, right? This is all you know. You should know about drawing these kind of complex Lewis structures. Here the complex Lewis structures means the structures with more than 2 central atoms, right? Okay, that is all about the theory regarding that.